This is David Kidd with the Lynn Benton Community College Transfer Engineering Program. I'm just going to cover a brief overview of our program. Most of our students go to Oregon State University, so here's an overview of some of the majors at Oregon State. The civil engineering related majors focus on public works, roads, bridges, pipes, buildings, things like that. Civil engineering focuses on the design of these things. Construction engineering management focuses more on the construction of them. The mechanical engineering related majors are mechanical, which focus on moving machines that transmit power, manufacturing, which focuses on the process of manufacturing things, industrial, which focuses on quality control and efficiency in any sort of process, and energy management, which is offered out at the Bend campus for the junior and senior years. So you can do the first 2 years here at Lynn Benton and at Oregon State, at Corvallis, and the last 2 years of energy management are offered out in Bend. Electrical and computer engineering focuses on anything from power distribution to computer engineering. Chemical, environmental, and biological focus on controlling processes. So you see there are those large water tanks. An environmental engineer or a chemical engineer would focus on controlling the water treatment process that is occurring in those tanks. There's a number of other engineering-related majors at Oregon State. And there are some common engineering majors that are not offered at Oregon State, but are very common. Aerospace and mining are two that come to mind. I often have people ask me which engineering major is the right one to choose. My response to that is to think of what you would like to spend 30 years of your career doing. Don't worry so much about getting a job or how much money you'll make. Engineers generally do very well at both of those things. So after you graduate and move into the workforce, you'll typically move around a little bit until you find a niche that you're comfortable with. So just think with your major of something you'd like to be doing for 30 years. All right, engineering is an interesting and challenging career where you use technology. It has excellent employability, pay, and career advancement. Now, there are important skills that you need to have to succeed in engineering. You need to be good with math and technology. You also need to have the time and commitment to work hard at it every day. So those are two of the common things that you need to succeed in engineering. Now, engineering careers focus on a broad variety of things, from design to modeling whatever it is you've designed, to construction and fabrication of that thing, and also the operation and maintenance of it. So engineering transfer, which is our major, focuses primarily on the design of things. We have other majors at Lynn Benton Community College that are engineering related, that focus on some of these other things. So modeling is covered in our CAD technology and civil engineering technology programs. Construction and fabrication is covered in our welding technology and machine tool technology programs. Operation and maintenance is covered in Mechatronics and water and environmental technology. I bring this up because I think a successful career is built on matching your personal skills with the skills required for the career. Now, in transfer engineering, which is what we're talking about in this video, the skills you need are higher level math and analysis skills. These other majors at Lynn Benton Community College have different skills that are required. Drafting and CAD require visualization and computer skills. Civil engineering technology, you should be familiar with construction using a computer and have math and analysis skills. Mechatronics requires that you can diagnose and repair systems. Water and environmental technology requires that you have knowledge of environmental science and you have good hands-on maintenance and lab skills. Welding requires that you have fabrication, material analysis, and layout skills. And machine tool technology requires that you have fabrication, layout, and computer skills. So think of matching your skills to a particular major and career. Here are some examples of successful engineering-related careers of LBCC graduates. Now, students in the transfer engineering program transfer to OSU and other universities, and they become design engineers and engineering managers. Drafting and CAD students, an example of a successful career would be to be a CAD department manager or a designer. Civil engineering technology graduates, when they're successful, they become surveyors, GIS managers, and designers. Successful careers in mechatronics include robotics technician, industrial machinery mechanic. We have graduates of the Water and Environmental Technology program that have become water plant superintendents and public works directors. Some of our welding department graduates have become aerospace welders, shop superintendents, and estimators. And machine tool technology graduates have become CNC programmers and shop foremen. So any of these majors lead to successful engineering-related careers. And here are just some examples of some of the things that our graduates have done. So I would just encourage you again to match your skills with a major and a career that will lead you to be successful. There's many pathways. Now, of course, this video here is focused on transfer engineering, so let's continue looking at that. Now, the vast majority of our students go on to Oregon State, so let's talk about that program and how it works. Oregon State has broken their program up into two parts. The first part is the freshman and sophomore year, which they call the pre-engineering portion of their program. This involves taking basic generic math, science, and engineering classes. You take them with a lot of students from a lot of different majors, and you're preparing yourself for the last 2 years. The last 2 years, you focus more on your major and you focus more on design and analysis. So what Oregon State University has done is create a door between the sophomore and the junior years. Freshman and sophomore years are pre-engineering, junior and senior years are pro school. Now, if you want to take a junior level class in your engineering major, you have to be accepted in the pro school for that major. So to get into pro school, to get into the junior year, you have to meet certain requirements. You have to complete at least 80 credits of the engineering program, which usually isn't a problem. Students at that point have always completed 80 credits from my work here at Lynn Benton Community College. You have to have applied to and been accepted to Oregon State University. You have to complete the engineering core for your major. You have to apply to pro school and have a high enough core GPA to get in. Okay, so those are the requirements to get into pro school. Now here's a generic curriculum that would involve the first and second years of a typical engineering program. Now notice the first year starts when you get to Calculus 1, Math 251. Okay, that's when we consider someone to be a first-year student. So in that first year, they take Engineering Orientation 1 and 2, ENGR 111 and 112. They take their beginning calculus, Math 251, 2, and 3. They'll take their chemistry sequence, writing, communication. They could take some of their liberal arts perspectives, and lifetime wellness, biology, and some other miscellaneous engineering classes. In the second year, a student will typically take Advanced Calculus 254, maybe statistics there, or another vector calculus class, and then differential equations, Math 256. They take physics 211, 212, 213, and then they'll take engineering classes that depend on their major. We have two basic engineering sequences, statics, dynamics, and strength of materials, engineering 211, 212, 213, and then the electrical fundamentals sequence. DC analysis, which is 201, AC analysis, which is 202, and then signals and controls, which is 203, and there's also digital logic design, 271, 272. Okay, so those are some of the engineering classes that we offer in the second year. Now this is a generic curriculum. Your curriculum will depend on the major that you're taking. So you should look for the specific advising sheet for your major. Now notice that some of these classes on this list are bolded. Those are typically the core classes that OSU will look at. They'll get your GPA in these core classes to determine whether or not you get into pro school. Now, the ones that I've bolded are typically core classes. The actual core classes that are used, again, depends on your major. You should look at an advising sheet to really determine what those are. Typically, to get into pro school, if a student has a 3-point in the core classes, your odds of getting into pro school are very, very good. Okay, so that's kind of a mark that I would shoot for once you get to these engineering classes, is to get a 3-point GPA in the core classes, in the first and second year classes that are bolded on your advising sheet. Now, another thing you're doing when you're here is you're working on an Associate of Science degree, which feeds right into the Bachelor of Science degree. So here are the Associate of Science degree requirements. Writing 1 is Writing 121. The second writing class for engineering has to be Writing 227, Technical Report Writing. That's the only one that engineering will accept. Similarly, speech has to be COM 111 or COM 112. They'll accept those classes, no others, so you take one or the other. You have to take math. You have to take a lifetime wellness, which is PE 231. You have to take a biology class of the lab. And you have to take physical science, which engineers take chemistry and physics to meet that requirement. You also have to take liberal arts perspectives classes. There's 5 categories, 1 class from each category, no more than 2 classes with the same prefix. So the 5 categories are cultural diversity, difference, power, and discrimination, literature and the arts, social processes, and Western culture. So 1 class out of each of those categories is the idea, no more than 2 classes that have the same prefix. They want you to take a broad base of these classes. So these are the things that are required for an Associate of Science degree, and that feeds right into the Bachelor of Science degree over at OSU. Now, to get a bachelor's degree at Oregon State University, you're currently required to take either 2 terms of college foreign language or have had 2 years of high school foreign language, so one or the other. Now, math is kind of what you would call the critical path to get through your engineering schedule. Where you are in math determines how quickly you can get through engineering. Generally speaking, it's a bad idea to try and rush your math. So take your time, learn it well. It's the foundation of a lot of what we do in engineering. The other thing I'll mention is that early on, your performance in math is probably the best indicator you have of how successful you will be in engineering. There's the math sequence. You start wherever your test scores indicate and then work class by class through the sequence. Now, many of the first-year engineering classes have a prerequisite or co-requisite of Math 111. Many of the second-year engineering classes have a prerequisite of Math 252. So those are the classes you have to get to really be a fully engaged first or second-year student. Okay, so keep those classes in mind. Those are the marks that you're really a first or second year student. So you should have completed Math 111 or at least started it at the beginning of your first year. You should have completed Math 252 before you start your second year because it's a prerequisite for most of the second year classes that you take in engineering and physics. Okay. Now keep your eye on how you're performing in math. If it's not going well for you, you might think of doing one of those professional technical programs I mentioned earlier, that such as CAD or civil engineering technology, or water environmental technology, welding, machine tool, mechatronics, things like that. Okay, find a major that fits your skill set, and you'll succeed. One other thing I'll mention here is that it's a good idea at some point to use the LBCC OSU degree partnership program. That allows you to enroll at both schools at once and allows your records to go back and forth easily. Some majors, actually, it's pretty much required that you would do this. Not all, but some of them. It's something I look at in the first or second year of engineering. I like to get this taken care of so that I can apply for pro school smoothly. Okay, that's just a quick overview of the transfer engineering program at LBCC. You can work with your advisor with any questions that you might have.